Hello guys, so welcome to my channel Plan 3D tutorial, and in this video I'll be teaching you basically all the basics of Plan 3D tutorial. And by watching this video you will be able to crack your at least your tool test of any company which you are going to interview in. In this video I'll be teaching you starting from the creation of project, then going to equipment modeling, structural modeling, and some part of isometric extraction. Then we have the piping layout extraction. So basically you will get a complete package of an idea of what is Plan 3D and how it works. And so without talking anymore, let us start the session now. So let us begin with the project creation. To create the project, first you can see there is two options, like one is open and one is new. So right now we are creating a project, so let us go for the new option. So I'm clicking new. I'm entering the project name. Let me enter just like tool test, and if you have any optional description, okay, you not worry about that. And next we have to select the path on which the project has to be saved. So I'm just setting it the default path. I'm not changing it. If you click on these three buttons and three dots, you can change that. So, and we have an option like copy settings from existing project. So basically if you want to copy some settings which were predefined in some of the project, so you can click this and then click on the three dots and select the project and the XML file, and the settings of the previous project will be copied. So right now we need not worry about that. So let us click on next. Here we have to select the units, basically like imperial or metric. So normally I'll be selecting metric, and it differs from project to project. So for now let us select metric, millimeters, and let's go to next. And here we have a directory where the P3d drawings are stored. So P3d directory we have to select, or it will take the default where you have selected in the previous page. And here it defines the symbols, whether P3d symbols like DIN standard, PAP, or whatever. And let us just move on next. And here the directory of all the drawings which will be saved, like spec sheets, orthographic output, and then we have the directory for what is this? Supporting files. That is actually related to the project. So let us not worry about that and move on next. And this is for like single user or multi-user if you're working on server, or for that. For now it is a single user, so I'll be selecting this single user. Next. So next, that's it. You need not check this and just click finish and your project will be created. It's taking time. It will depends upon the speed of your system and everything. So I'll just have. So guys, as you can see, my project has been created. Here you can see, you can expand and minimize the project. And here we have the P3d folder, the Plan 3D drawings folder, pipe spec, where we have all the specs. And you need not worry about this right now because this is the admin part. So, and any supporting files can be stored here. So let me tell you that I would be doing an equipment. I'll just show you my files. Okay, yeah, as you can see on my screen, and this is equipment. So I'll be modeling this equipment, and we would be modeling some 2 or 3 pumps like this, and basically we're doing this P3d. We'll be working on this P3d. This P3d was given to me during a tool test in one company. So let us follow the same thing. I have hidden the company name and everything. So let us go back to our Plan 3D. So let me create one file for the tank, that is the equipment tank, new drawing. I'll name this tank as tank 001. Okay, so guys, as you can see, my file is created, and when we will be modeling the first equipment by referring to this file. And by seeing this, you can see there is a head, then cylinder, then comes a cone, then again a cylinder, then we have a cone, and the last we have a nozzle. So let us first give the shapes. And this is the ribbon bar from the home. So we'll be talking about ISOs, structures, these three in today's session. So first let us go to the create equipment. You can see equipment, then here create, click it. Then we'll be going for a tank which I'm creating. I'll take it as a new vertical tank. So I'll be adding shapes. First was a head. I'll be taking this torospherical head. Then next we had a cylinder, cone cylinder. Okay, a cylinder. Then again we had a cone. Then again we had a cylinder. Then again we had a cone. Okay, let us give the dimensions now. The first diameter is 1100. So torospherical, the diameter here is asking diameter 1100, and here okay, we can switch on this dynamic thing, and if this is activated and putting it as 1100, the next equipment will be considered 1100. As you can see, I have given 1100 here. The cylinder is also 1100 now. Okay, you can also deactivate it by clicking on this pencil. Okay, so let us, this SF is this distance of next to the head. So right now let me see what is the distance. The distance is not given here, so let me just put it as 0. Then thickness I'll just consider randomly like 5. Okay, next the cylinder diameter is 1100 done. Then height of the cylinder, it is given as 2471. So okay, so let me give it as 2471. Cone D1, we have D2 it has taken as 1100. So this D2 is 1100, and which is the major this minor dia of the cone, and the next dia is 2200. You can see here 2300. So D1 will become 2300. Height of the cone, we need the height is 1039. So 1039, and this E is offsetting the cone and A is the angle, so let us not worry about that. And moving on to this next cylinder, it has taken automatically as 2300, and height of the cylinder is 3900. So let me give it as 3900. And next we have the cone. You can see this is the cone. The major dia is 2300, and next dia is as per the size of this nozzle. Okay, and let me just check the size of the nozzle here. A is 500, so let me just give it as 500 only. Okay, next cone cylinder. Okay, cone, then D2 will become 2300, D1 will become 500, and height of the cone we have to check here, that is 1990 minus 450, that will become 1540. So let me just give it 1540, and I'm ignoring this. And you can give the tag here, TK001. okay, sorry, TK will be here and 001 will be here. Okay, assign. So we have assign, and if you want you can give the elevation where the tank is resting. So I'm not giving that now. So let us create, and it should appear here. Yeah, I'll be placing this on the 0 axis, 0.0,0. Yep, and let me just give it to the north direction. Okay, so basically our overall structure of the equipment is done. So this comes in shaded, and you can see here, if you click, you can see 2D wireframe, and there are different types of viewing methods. You can explore this. I am just using this in 2D wireframe. So now let us add nozzles to this equipment. Okay, 1 minute, let me just delete this nozzle. Okay, So basically we have two methods of adding the nozzle. One is when you click this equipment, you can see this nozzle symbol. If you click this, it will take you to the nozzle screen, nozzle adding screen. And other method is where you select this equipment, right click, add nozzle. So both methods are same. You can see which one is easier for you. You can follow that. Let me just give you first nozzle N1, nozzle N, the number 1, the nozzle tag. It's close, and we have two bars here. First is to give the size of the nozzle, and the next is to give the position of the nozzle. So let me first give the size of the nozzle, and I'll be just modeling like the main nozzles which are used for piping, like this outlet nozzle, and that is this nozzle, like this nozzle, and probably I'll be adding one manhole. That's it. And later on, you can, if you want, you can model all the nozzles by following the same method. So let me just first give the nozzle A. Nozzle A is 500 size. This is nozzle A. So, and the height of the nozzle is 450. So nozzle A is 500. Let me just change to NA. Okay, yeah, 500. And this, let me just put it into inches. In pressure, let me just give it as 150 rating, and select the raised flange. Type of nozzle, this flat face, we have ring type joint flange, and this is the raised face flange. Okay, and so the size of the nozzle is done. Now we have to give the position of the nozzle. Here when you see, there is written as nozzle location. Here we have top, then bottom, radial, line, and nozzle. Okay, first top, when if you select the top, the nozzle will be positioned on top of the equipment, where you have to give the radius and rest of the data. Then next, if you select the bottom, where we need in this case, as the nozzle is in the bottom, it will come to the bottom of the equipment. If you give it as radial, it will go on the surface of the equipment on sideways, and where you have to give the angle and rest of the data. And then you have a line option. Line option is for the line option. First you have to create a line somewhere in the equipment, and then you have to select that line so that the nozzle gets placed on that equipment. So this is just a brief video of Plan 3D, so I won't be explaining each and every part of this nozzle placing. So we'll do it in some next videos. So for now, let me just put as bottom, and this one is to place the nozzle on some previous created nozzle. Okay, so let me just give it as bottom. Okay, the radius is 0 since I want it at the center, and the length of the nozzle was 450, and an angle, and this all things will be 0, which I won't be explaining it today. Okay, let me close this. Okay, so the nozzle is created, as you can see. Nozzle NA 20 inch, that is 500, ASME V16.5, race flange type, and 150 rating. So of equipment 001. I don't want this, just, and okay, if let me 1 minute, I'll just undo it. As you can see, there is a nozzle, and in any case you want to edit a nozzle, what you have to do is, you cannot just click the nozzle and go to the edit part. What you have to do is press control, hold the control, and then click the nozzle, and you can see this pencil, and then you can click the pencil and go to the nozzle sheet, and you can edit the data of the nozzle. Okay, so I don't want this nozzle now. I'll press control and select the nozzle and just delete. Okay, so I'll save it. Saving is just Control S. Okay guys, let us add the nozzle again. I'll be selecting this equipment, clicking this nozzle symbol. Take me to the screen, and next is, let me just name it as NB, the second nozzle. The size of the manhole. Here you can see we have straight nozzle, which we have created, the first one. Then we have a bent nozzle, then we have a vent nozzle, then we have a manway. So right now I'm just teaching you about the straight nozzle, and we'll be covering the manway. This you can explore, and it is not a very difficult part. I think you can learn it, or else we'll cover in separate equipment modeling thing, which I'll be giving in full detail of each and every aspect of this equipment creation. So right now I'm giving this as manhole. Then size of the manhole, what is the tag? I think it is D. Let me just check. Manway. Size of the manway is 750. Okay, yeah, and the length of the manway, I think it's not given here, so let me just consider it as 250. Size is 750. Okay, 715 inches, and there are two things. One is D equal to 3 inch, and other is the oval type. So I'll be just going for the D equal to 30 inch. Sorry, 30 inch it is. Okay. Then next, our manway is on the radial side of the equipment. So I have selected radial here. Height is, let me see. Height is it is 19903900, and just make sure the height of the equipment should be considered from here, the part of the equipment, not from the bottom of the nozzle, but from the equipment where you had initially modeled. So this is 1900 minus 450 plus 3900 plus 1039 and minus 650. So I think that would be around 5829. You can calculate if you want. It is 5829. The next, it is length of the nozzle. Length I'll be giving it as 250. An angle, and angle is that orientation. You can see orientation. You can just click here on this box for different viewing angles. Okay, I want it at 90 degree. That is okay, it is clockwise. Okay, anti-clockwise. So I'm giving it as minus 90, so it comes on the east side. Okay, if you want to offset the nozzle from the center somewhere here, so you can give the value here. And I is the angle of the nozzle, so I would be rotating this by an angle. This is 60, then this would be, I think, 30. Let me just put it as, let me first put it in front view. Yeah, okay. Let me just put it as 330, sorry, 30. Yeah, perfect. And N is the angle to be rotated in the horizontal plane. T is like rotating the nozzle through the face. If you see to the face, through the axis of the nozzle. Just we have given the values. So now length, I think this is very less, so I'll be giving it as 350. Yeah, 350 is fine. See, we have length here and we have one more length here. So the assignment is, what is this W length used for? Okay, I'll closing this. My nozzle is created. Okay, by following the same method, you can model all the nozzles for the equipment if you want. I'll be sharing this PDF with you, or probably not actually, because this is of some company, so better you can take anything from online on the internet and model the nozzles. Okay, let me close this. Okay, my first equipment is done. Okay, let me just put it in the layer. Okay, layer modeling is same as AutoCAD. Let me just first create a layer command, then I'll put it as EQP equipment, sorry, EQP, and color, let me just select randomly and give it this. Okay, I'll select this equipment. Layer is EQP. Done. Save this. Okay, let me see what else. Okay, we have some supports here. Okay, fabrication of support. Okay, let me not give this. I'll be giving some lug support here. So to add the lugs, you have to modify in the equipment. So how do you get into the modification field, modification sheet? You click the equipment, right click, and get into modify equipment, or else you click the equipment. Here you can see, sorry, not here. Yeah, here it is, modify equipment. You can get into the modification sheet. Okay, what do I want? I want lugs. I want lugs on where? On this cylinder. So modify equipment. I'll be selecting this selecting this cylinder, and this hierarchy. So this is that cylinder. So here we have add shape, add trim. For if I click add trim, you can see what do you want to add. It is asking me. So stiffening rings, skirt. Next stiffening ring is this. Don't want that. Stiffening ring, skirt for the rest support. I don't want that either. What I want is a lug. I would be lugs. Here you can see we have platform, lugs, legs, body flange. I want lugs now, so I'll be selecting lugs. I'm just giving some random values. You can take some proper equipment from the internet and model it according to the dimensions. So I want 4 lug supports. Height would be this height is considered from this edge of the cylinder. So height I want it to be 500. What is h1? H1 is height of the lug excluding the base plate, so that I'll be giving 150. Length of the lug, let me just give it as 350. Then L1 is this, okay, chamfer length, that also will be giving us 50. L2 is this chamfer length, that also will be giving it as 50. Thickness of the base plate, let it be 20. T1 is this supporting, what do you call this, reinforcement plates. Yeah, thickness, and this T1 is the thickness of this reinforcement plates. Let me just consider it as, let me give it as 10. W is the length of the base plate, that let it be 200. This distance between the reinforcements plate, 150. Let me just give it as 125. I'll give it as okay. Okay, this looks a little smaller. Okay, I'll just click modify equipment and increase the W 350. Okay, this will give it as 250. Height also will be increasing. H1 250. Okay, let me see now. Yeah, perfect. Okay, this looks good. So this our equipment is done. As I told you, you have to model all the nozzles of, you have to take some equipment, you have to follow the same method of model and adding the nozzles, and if you have any queries, you can comment in the comment box. So next, if I see this PNID, you can see there are 3 pumps. These are 3 identical pumps, so I just need to add model 1 pump, and the same pump can be copied for all the 3 files. Okay, let us just model the pump. I don't have the GA of the pump, so I'll just be modeling roughly through my knowledge, and we'll be giving the size of the nozzle. One size less than the pipe size. Pipe size is 10, so I'll be considering this as 8-inch nozzle as inlet, and this I'll be considering a 10-inch nozzle as outlet. So now let us create the pumps. Let me first close this file, or else you can also keep it as open, not an issue. So I'll right click this on Plan 3D drawings where I want my pumps and 3D models to be stored. So right click, new drawing, P, I'll give it as, sorry, P1001. Okay, now as you can see, I want 3 centrifugal pumps, and first one is this. You can name anything. I have just given random name. Okay, width inlet is 8-inch, one size smaller than the line, and here it is 10-inch outlet. Okay, we'll click on create equipment. Okay, create equipment, and here you can see we have different thing, blower, centrifuge columns, everything. What I want is a pump, so pump is here. And which type of pump do I want? I want a centrifugal pump, so I have to select the centrifugal pump. Here is the centrifugal pump. So what is the tag? This P1001 assign. Okay, so this values, you can get these values in the pump GA. So right now I'm not having any pump GA, so I'm just giving some random values. Okay, SL is the base length of the pump. Let me just give it as 1.5 1500 mm. SB is in Y direction. I'll give it as 650. SH, what is SH? Height of the base. I'll give it as 200. SI is distance, center distance of the nozzle till the edge of this base. So SI, I'll just give it as 150. SO, center of the inlet nozzle till the bottom of the base. I'll give it as 500 maybe. This all values you will be getting in the pump GA, so I'm not changing this now. Let me just see if it gets created. Yes, it is done. Okay, I'll be placing it on 0. Done. And I want this towards the north, or else let me just place it like this. See this in the front view. Yeah, this pump is okay. So now what is that inlet size? Inlet nozzle is 10-inch and outlet is 8-inch. Okay, inlet nozzle was 10-inch. So 10-inch is 250. Okay, then outlet was 8-inch. 8-inch is 200. That is okay. Okay, sizes I have given for both the nozzles, and if I want to edit the nozzles, look, N1, I'm clicking here. You can see all the nozzles of the equipment. I'm clicking on N1, and N1 position I have to decide. So change location from center till the end of the nozzle. How much is the distance? Actually, I don't have that, so I'll be giving it as 250. Yep, you can see. You can change this. I think you need not worry about this. This is the main thing. And N2, I'm not covering this part here today. N2 is 200, and what is that location? It is asking from center till the end of the nozzle. Oh, sorry, you have to just give it some random value. Let me just give it as 350. Yeah, 350 is fine. Okay, I'll be closing this now. Okay, I feel this casing is a little bit small, so let me just edit this. Editing is same as what we did in the previous model. Okay, so I need to increase the diameter of this casing. And where is that casing? Yeah, DC, a point DC. Let me give it as 250 and check. Okay, I'll apply here itself. Yeah, it's fine. Okay, this looks good, and I've created my pump. This is an approximate model. You can refer any GA online and model by seeing that GA by following this same method. Okay, so let me just put it in the layer. Okay, I have to create a layer here. LAY. Click on this new and put it as pump. Okay, the color of the layer, let me just give it as yellow shade. Okay, yeah. Okay, close. Put this in the layer. Okay, this looks this. Okay, we have to follow the same method for the next two nozzles. Two pumps. So I want the same type of pump but in different files. So what I'll do, either I'll create two files. Okay, new drawing. P1002. Okay. Okay, my file is creating. Okay, it's done. I need one more. P1003. Okay, there are actually two methods to copy a pump. Either you can just select this pump, Control C and Control V in the next file, or else you can go to this location of the file, copy that file and paste it 2 times and rename that file. And coming here, you can copy the drawings to project. That detailed video will be covering it in the next video or any other time, but right now I'm just doing the Control C Control V part. Control C. Okay, I've copied the pump and I'm pasting it. Keep this pump at 0, 0, 0. Okay, so okay, I'll assign the tag because this is not 1001, this is 1002. Save it. The next is 1003. I'm pasting the same pump on the 0 point. Okay, and again I have to change the tag. Sorry, again I have to change the tag for the pump. Assign tag 1003. Okay, I have so according to this PNID, my tank has been created, and this is not exactly the reference tank. This is just a representation. My tank has been created, my 3 pumps has been created. So now we have to go for the piping. Okay, before the piping, let us learn something about the structure. Okay, done. Let me just close this equipments. Okay, yeah, save it. So first thing I need to create a new, let me just create a new folder where I'll be storing my structure. So that I'll be naming it as layout. Sorry, layout tool test. You can name your file anything. Okay, better you create a folder like equipments, new folder, equipments, yes, equipments, and in that folder it's better to create this equipments. So right now I'm not doing that, you may follow that. So here, okay, so let me create the structure folder here. Right click, new drawing, name the file as structure. Okay, structure, structure. Okay, so okay guys, my file has been created and I need to model the structure now. So you have to, what first we have to select the structure structure here. Okay, 1 minute. Okay, you have to select the structure here, and you can see we'll be working on this tool here, parts here. First we have structure, grid, railings, stairs, plates, footings, ladders. So now we'll just be working on here. You can see settings. Settings are used to change the size of the members, railings, footings, stairs, or whatever is used, and this is used for the representation of the structure, the beams, this line model, or we have some symbol model, outline model, or shape model. So first let me just plan before creating the structure in 3D. Let me just put a grid now. Using a grid name will be test, it's fine. Yeah, axis value, axis in X direction. In this direction, how much points do I want? First will be 0, then other will be 6,000, the other point will be 12,000, because I want base of size 6 meters. The names of the points will be ABC, that's fine. And in this direction I want 0, 1 point at 0 and other point at 6,000. Okay, let the names be 1 and 2. And the platform values, the height of the structure. First I need 3.5 meters. 3.5 meter. I think I don't need this, so I'll remove the second point. So I'll remove this. Let me best put it as 3500. Okay, UCS, WCS, this coordinate system. Okay, we'll click here. Okay, yeah, our structure line diagram has been created. So first, okay, fine, let us just model the structure first. And the size, I want to change the size of the beam. So here, if you click on settings and change the member size, you have different types of members here and different types of standards here. So I want a HEB 500, and this, you have different points here. This point will be taken as the, wherever you click on the screen, this point will start the beam at this point. Okay, member. So I want one column from here. Okay, first I want to change this to the center. Okay, so I want a column here, so from here to here, that's it. Again, starting point, I'll select the start point, end point. Again, I'll select the start point, end point, start point, end point. Or else you can just click create one and copy all four. So next I want beams. So okay, I want columns here as well. Start point, end point, start point, end point. So I want beams. So on. Okay. So I'll be selecting this start. Okay, let me just change the settings. This end point. Okay. Okay, let me just now give the start point of the beam. Before changing that, I'll be changing the starting point. I'll be selecting the top of the beam. Okay, member, mid, and this end. I want this start from the mid till this mid. Okay, then I want to start from this mid or end till this end. Okay, so let me just copy now. This I'll copy by distance of 6000. Okay, this I'll copy by 12,000. Okay, our small basic structure is done. Now you can give footings here by using the footing commands for the structure. I won't be modeling the footings here, I'll just put the 3D extrusion. Okay, let me offset this by 100. Yeah, okay. Let me extrude this by 200. Yeah, fine. And I'll just copy the same footings to all the beams, columns. One is at 6000, the other is at 12,000. Okay, now same 3 footings to be copied at this distance, 6,000. Okay, so our basic structure is done. So I won't be giving the stairs actually because it would take a lot of time and the video will become big. So let me just cover the stairs things in the next video. So let us now place the equipments. Before placing equipments, let us place the structure in a separate layer. Okay, I will name it as TRUC structure. Okay, well, the color, let me just give it as something as gray. Okay, this is fine. Okay, so this all full structure, let me just put it in the structure. Okay. Oh, I think the color is a little bit dark. Make it as, yeah, fine, this is fine. So you can see the structure in 3D looks good. Okay, now let us xref the equipments. What is xref? Xref is like you are placing the equipments on just the model of the equipments of to the respective position in the other file, where you cannot edit the equipment, but you will see the equipment here. So first I want my 3D, I mean the tank, this tank, I want the tank to rest in center of this structure of this bay. So let me just see center of this bay. So what will be the coordinate of the center? I need to find out the coordinate of that center. Okay, so I want the center of the tank to be here. So I'll use the id command and I'll see x 3000, y 3000, and z is 3500. So to that coordinate I'll be moving my tank. That is x should be 3000. Move. Okay, let me on this. Okay. 3000. In y it has to be 3000. Okay, z has to be 3500. That is this point. This height should be at 3500. Now it is 40. I have to move it to 3500. Okay, now it is perfectly on its coordinate, so I'll save it. Now let me just xref the equipment. Xref, you can see the xref bar opened. Click here and you have to select the file location, tool test in that plan 3D models. In that I have the tank here. I'm selecting the tank and just clicking open. In this screen you can see it is asking if you want to change the scale, and on the screen you have to check this. I normally better to uncheck so that we have the 1:1 scale. Insertion point you can either insert it on the screen or just let it come as it is placed in its original file. Here we have overlay and attachment. We'll talk about this later, so I'll just keep it as an attachment and I'll give it as OK. As you can see, my equipment has automatically been placed on the center of the structure. Okay, I'll save this. I think this height of the structure is not sufficient, so let me just change the height to 6 meters. Before that I have to change the grid size. This as 6 meters, this as 6. Sorry. Okay, I have to move this to that point, another 2.00. Okay, and I have to move this equipment. It's better not to move the equipment directly in the structural file. You have to get into the actual drawing and let us move it here by 2500. Save it, and I'll just, you have the update prompt here. Click it. It is asking this is the new position and the old position, and yes, it's good. Yeah. Okay, so now let us save this and xref our pumps. I'll give the xref command. I'll go here, click, attach, and I'll select the pump. With one pump, attachment. Okay, so as you can see, it has come at the 0 point. This is the location where our pump has been placed. As you can see here, it has been placed here. So what I want to do is I want to place the pump in this bay at some certain distance. Probably let me just check. Okay, in x direction I want the pump to be at the position of 6 meters. 6. Okay, and in y direction I want it to be at the position of 1 meter, and z is 0. Okay, so I'll be in x direction. I'll move this at a position of 6 meters. Y direction I'll move it as 1 meter and save. Let me see the structure and update. I'll accept this. Okay, this is fine for me. Okay, the next pump I want it at 6 meters in the x direction, and y direction I want it 1 plus 1, so 2 meters. Okay, let me just move it. Okay, 6 meters, 2 meters. Okay, let me check if that looks good. Okay, pump 2. Okay, let me just xref it first. XA, you can just give the command XA now and open and okay. Okay, let me move it to the center. Okay, how much distance do I need to move it? Y is another 1 meter. Okay, I will move it by another 1 meter here. 100. Save it. Come back here and update. Okay, accept. And the next is this distance looks too. Okay, let us move this by another 350. We'll basically keep the distance between pump as 1 meter. Okay, another 350. I have to move this pump in the y direction. So I'm moving it as in y direction as 350. Save it and I'll update it. Update, reload. Okay, I'll accept. Yeah. The next I have to move the pump. Except of this pump, this will go 6 meters. And here, let me give it as 5 meters or 4.5. I'll check it later. Okay, we'll put XA command and open. Click close. Okay, and this looks okay. 850. Okay, let me just move it. Okay, sorry, by 150 more. 150. Save. Go to structure. Reload. And okay, so you can see we have created our basic structure. We have placed the equipments by using the xref command and along with the pumps. So I'll save this, and what I have to do now is create the pipe routing for these pumps.